right, let's pull up on the screen our algebra class, see what we're looking at this week. I know we got two lessons that are both kind of packed, so afraid it's going to take a little time today to get through this. All right, first hour, Algebra 3. Here we go. Let's see, going to our grade screen. Let's see, we're done with the test last week. See, my fake student, he didn't do well in the pretest. He did better on the practice test, but then he aced the test. So good job. So he's got 100 in the class because the pretest and the practice test are practice grades. So they don't count. The only one that counts is everything else. So if you've taken the test and didn't do well, you can retake it. You need to email me. And then I'll send you a problem or two that you missed. You need to review it, tell me how to do it properly, and I will reopen the test so you can retake either part one or part two or both. So this week, let's see, looking over here, we've got two lessons. Oh, this module is going to go fast. We got a lot to cover this semester. Because next week, we're going to do 3 lessons and then test after that. So we just got 2 weeks and we're going to test. So that moves us along pretty quick. But we're going to look at functions and their properties and graphs of functions. And there's a lot in this. So we're going to try to get to it as quickly as we can. Oh, back here. I went to the wrong screen. Okay, I'm going to close module 1. Module 2, here we go. Functions and their properties. Functions and their properties. So this is laid out a little differently because we stole this module from pre-calculus class. Last one we stole from Algebra 2. Like I said, Algebra 3 only exists in Arkansas and not exists in every state. So some states don't have this. I'm going to make this bigger on our screen. Yeah, that's pretty good. We'll see if that's too big. All right. The way this is laid out, this module, it has a scenic overlook. All right, so the scenic overlook is like a summary of the lesson. And that's all this up at the top. Okay, so we'll go down through this. Scenic overlook. And then you'll get to the actual lesson. 1.2 functions and their properties is what it has. We're using this 2.01, but in pre-cal this is 1.2, chapter 1. So here's the actual lesson, and the lesson goes into a bit more detail than the scenic overview. Scenic overview is like the summary. So in our class, we're going to look at the scenic overview, which summarizes the lesson below that. And if you need more information and you're struggling with it, go and look at the full lesson down below, which gives more information, goes into more detail. All right, so this is a machine diagram for a function. Input the X, output the Y. You may have seen that before. A bit of history over here. It's got a whole lot more information. So you can go through all that if you need to. But we're going to hit the highlights with the scenic overlook. All right, so functions. Functions exist in life. So here's the part, functions in our lives. If we drive on the interstate at 70 miles an hour while traveling to Yosemite National Park, how far would we travel in a given number of hours? Okay. Okay, I have to pause for a second. I see all these videos online where this guy goes to college campuses on the sidewalks, and he says, okay, let me ask you some questions. Like, sure. He'll say, if you're traveling at 60 miles an hour, how far will you travel in 1 hour? And they'll go, 30 miles? 90. It cracks me up. 60 miles per hour. So if you travel 1 hour, you travel 60 miles because that's 60 miles per hour. It cracks me up. Just had to have an aside there because that's funny. People on college campuses can't answer basic questions. All right. So that's a function right there because it's for every hour you travel 70 miles. That's a function. Here's another function. If I purchase a certificate of deposit paying 4.5% interest per year, which right now they're paying 5.25%, how much would the certificate be worth after a given number of years? That's a function. If I were hiking on the John Muir Trail and could hike 12.5 miles per day, how far did I hike in a given number of days? That's a function. So we can create a chart to show this. So this is the miles per hour chart, right? So the X is the number of hours right there. The Y is the number of miles traveled. We can also write it as ordered pairs, 170, 2, 140, 3, 210, 4, 280. That's the X and Y, X and Y, X and Y, X and Y. And then each ordered pair, the first element is the number of hours traveled, and the second is the rate multiplied by the rate is the distance. So a function is defined. If we're going to talk about functions, we need to know what a function is. And this is not the first time you heard this. You heard this back in Algebra 1. Heard it again in Algebra 2. But a function, but this is putting it in language like college level math language. So we're going to talk about it. A function f from a set A to a set B is a rule of correspondence that assigns to each x, element x in the set A, exactly one element y in the set B. Doesn't that sound like real high-level math language? The set A is the domain, or the set of inputs, of the function f, and the set B contains a range. Basically, what that's saying is for every x, there is exactly one y. That's how we're defining a function. This is the real technical math language, which if you want to get into that, that's great. But it based down to for every x, there is only one y. That's a function. And the x's are the domain and the y's are the range. So here's the characteristics. All functions have these three characteristics. For every value in the domain, there's only one corresponding value in the range. Which for every x, there is only one y. That's what that's saying. All elements in the domain must be used. Take all the possible x's. And more than one value in the domain can be matched with the same value in the range, right? Which means if x equals 1 and y equals 5, that's okay. There's only one y for that x. If x equals 2 and y equals 5, that's okay. It says more than one value in the domain can be matched with the same value in the range. More than one x can have the same y. You just can't have more than one y for each x. If x equals 1 and y equals 4 and 5, that's not a function because there's only one y assigned to an x in a function. All right, so here's a test your skills. This does have this in here, a chance to see if you know what you're doing. Use the set of values 1, 2, 3, 4 is the domain, which is the x's. -2, -1, 0, 1, 2 is the range, which is the y's. And which of the following represent valid functions using these numbers? And so it gives you this. And then hit this little check your answer. It'll open up a separate Google Doc to check your answers. So you can do these things and check yourself, just like in the other curriculum. It may load slowly like this, but at some point, there you go. A, B, C, D, E, F, there's all the answers right there. So when it has these check your answers, you can do that. Test your skills. So we're not going to go over all those. That's something you can go back and see if you understand what a function is by checking those 6, see if you can do those. All right, functions in algebra. In algebra, we're familiar with expressions or formulas that we represent with an equation, right? The sets of ordered pairs can be shown as an equation with two variables. For example, y equals 2x plus 1 creates ordered pairs for every value of x. So for every value of x in the domain, there's a value that's derived for y. We can just put a 1 in for x, and we find out that the y is 3, right? So for 1, 2, and 3, it'd be 3, 5, and 7. Because when we put 2 in, 2 times 2 plus 1 is 5. So when it's 2, it's 5. The x variable is called the independent variable because we get to pick that one. We pick an x. We assign an x. We're going to say x equals 1. And then y is dependent because y is going to depend on which x we chose. Right? We're not choosing the y. We're going to say y equals 3. No, we chose the x and we had to put it into the expression to figure out what y equals. So what would the range be for the equation y equals 7 minus 3x if the domain is the integer values that only are between -4 and 3? Well, the way we'd calculate that is we'd put -4 in and solve that. And when we put -4 in, we find out the answer is -4 times -3 is +12. Oh, but it's greater than, so it doesn't include that. I'm sorry. -4 is not part of the domain because it's greater than -4, but not equal to. So it'd be -3 to 2. So -3 times -3 is 9 plus 7 is 16. So -3 matches up with 16. -2 matches with 13. So if this is the domain, -3, -2, -1, 0, 1, and 2, which it is because we limited it, the range would be the appropriate y's that match those x's. When we substitute those x's in, this is the y's. So that's how we find the domain and range if we don't have a graph. Determine the range for the following. Here's another test your skills. Y equals x, where x is between 10 and 20. Well, if the y equals the x, then the domain and range are going to be the same. Right? The range has to be 10 is less than y and less than 20 because it's going to equal whatever the x is. This is going to be twice what the x is. So that's going to be 20 is less than y is less than 40. And again, you can check your answers right there. All right, function notation. This should not be new to you either, right? Because we say y equals, but that's the same as f of x. So if we have the function y equals 7 minus 3x, we can write it in function notation as f of x equals 7 minus 3x. So that's the same as the y. And 7 minus 3, if x equals -3, -3 times -3 is 9, plus 7, 16. Y equals 16, or f of -3 equals 16. Okay, here's another test your skills that you can check your answers. Determine the value of f of x for the function f of x equals 7 minus 3x for the following. And it gives you 4 different values of x, and you need to find what f of x equals or what y equals. They're the same thing. All right, the domain of a function is all the valid values for the expression that defines the function. So if f of x equals 1 minus x, that's all real numbers because we could put any x in there. There's not an x that we could not put into 1 minus x. But for f of x equals 1 over 1 minus x, let's look at that a little closer. I'm going to put this up on the screen. F of x equals 1 over 1 minus x. Okay, we want to look at this as far as what is the domain? What is all the possible x's? Well, all the possible x's are in this case, what's not allowed. With a fraction, what is not allowed? Let me just put a blank fraction over here. Can we have any number on top in a fraction? Is there a number we're not allowed to have on top in a fraction? Can we put -5? Is that legal? Sure, we can have a fraction with -5. Can we have a fraction with 1,000? Sure, we can have a fraction with that. Can we have a fraction with 0 on top? Sure, we can have a fraction with 0 on top. 0 over 2 just equals 0, right? 0 divided by 2, it's just 0. But what about the bottom? Are we limited on the bottom? Can we have a negative number on bottom? Can this be -4? Sure. And we know we can have a positive number. But what? How about 1,000 divided by 0? Can we have that? No, we cannot divide by 0. We can't divide by 0. So this cannot be 0. 1 minus x equals 0. That's what's not allowed. So let's add x to each side. 1 equals x. So basically, the domain of this one is all real numbers except x cannot be 1. It can be anything else in the world but 1. All real numbers except x cannot be 1 because 1 minus 1 is 0, and now this does not exist. So it will be all real numbers except 1. Division by 0 is not a valid number. So the domain is the set of all real numbers except for what's not allowed. So looking at this, the square root of x, let's look at the square root of x. So if we have f of x equals the square root of x, we can take the square root of every number out there that's positive. We can take the square root of 0. The square root of 0 is 0 because 0 times 0 equals 0. What we cannot have is we can't take the square root of a negative number. We can't take the square root of a negative number. That doesn't exist. That's an imaginary number. So the domain for this would be x is greater than or equal to 0. That's the domain. As long as x is 0 or larger, we can take the square root of it. If it's below 0, it's not a valid number, not a real number. So that limits our domain. So it says the domain of f of x equals the square root of x is greater or equal to 0. So let's see, can we click there? No, that click doesn't work. Sorry. Here's another check your answer. Determine the domains of these, A, B, C, D. And again, if we click on that, make sure that's working. Yeah, here's check your answers. Again, it loads slowly. There it is. There's the domains. So if you want to test yourself on this, there's the domains. All right, and that's it. So that's all that we talked about in lesson 2.01 is defining a function and looking at the domain and range. Okay, so if we look at, we'll go ahead and shrink this back down and look at the assignment for this one. Determine whether this is the graph of a function. Okay. How do we know if that's a function? There's only one y for every x, right? So if you do that vertical line test, is there any x that has more than one y assumed? If x is 5, y is, it looks like it's about 1. If it's 2, it looks like it's about 3.5. But there's only one value of y. So as long as there's only one y, it's like, yeah, that's a function. What's the domain? Again, what number is not allowed? Anything that makes that 2 minus x less than 0. So you'd want to solve that for 0 and say x can't be a number that doesn't. So is it less or equal to 2, greater than 2, all numbers 2? Figure that out. What's the domain of this? This has more than one restriction because this has to be 0 or greater because it's the square root of. But any x down here that makes this a 0 is also a problem. So if this is x equals 6, 6 minus 6 is 0. 0 times anything is going to be 0. That's a problem. So you can't have 6. Can't have this. So you got to check a few things there. What's the range? So you got to check, figure out what's the range of this. What's the smallest possible y this could ever be? What's the largest, greatest y it ever be? Is it negative infinity to infinity? Is it all real numbers? It's not in this case. Try some numbers and put them in for x and see what the smallest number you can come up with. And this, determine whether the formula describes y as a function of x, which just means, is this a function? Is there only one y for every x? Y equals 9x plus 1. Explain how you know. Is this a function or is this not a function? Yes, it is because, or no, it's not because. So if you want both points, you need to do it because. This is actually a 20-point assignment, so these points are doubled. This is worth 4 points then. This is 20-point assignment. 5 questions. All right, let's look at 2.02. Graphs of functions. I'll go ahead and make this larger again. All right, there we go. All right, again, our scenic overlook. In the preceding section, we looked at functions as numbers from an algebraic viewpoint. Now we're going to look at them from a graphing viewpoint. All right, so we're going to learn to look at the pictures they generate and determine many characteristics of the function by looking at the graph. Using only the picture of a function, we can determine the domain, range, and some values. So Free online graphing calculator at desmos.com. I have a link to that. So when you click that, it will open up Desmos for you. All right, so there's Desmos. Okay, let's recall the graph of a function. Recall the definition of the function and apply it to a graphical representation. For any given x along the horizontal axis, there'll be exactly one y on the vertical axis. So any vertical line can intercept the graph at a function only once. So what does that mean? That means if we have y equals 2x minus 5, or if we have y equals x squared plus 1, anything like that, if we make a vertical line, y equals b, and I want a slider. Oh. Okay, it's not giving me a slider like I want. X equals 1. Let's do x equals 1. And if we say it could be any number between -5 and 5, step 1, let's see if it'll do it for. Yeah, here we go. See, as I move that line left and right, is there any place that crosses either one of those function more than once? Right, let's look at the red one. This vertical line, as I move it left and right, it only touches that red line once, no matter where I move it left and right. All right. If I look at the other one, it's only going to touch it once as I move it left or right. So this passes the vertical line test. Nowhere does it touch it. Now, if I change this, oh, now look, there's the vertical line. It crosses it right there at 3.111414 and at 3 negative. There's 2 different y's assigned to that x. When x is 3, there's 2 different y's. I can't say when x is 3, y is 1.414 because it's also negative 1.414. So this is not a function because a vertical line will touch it in one place. Now right there, it only touches it once. That's the only place it touches it. But I only have to find one place where that doesn't work. Oh, there's a place. There's a place. There's several places here it doesn't work. If there's just one place it doesn't work, that's enough to say it's not a function. Not a function. All right. So let's look at increasing and decreasing functions. Studying the graph can help you understand whether it's increasing or decreasing. So here's the graph they have for us. Look at the red line. It comes up, down, back up. This is a function because there's only one y. If I put a vertical line, it's not going to touch it more than once. But there's a lot of things. Right here, it's increasing all the way until it gets to this relative maximum. Now it's going down. The y's are going down. Then they're going back up. So this has increasing, decreasing, increasing. Now, relative max, that means that's the maximum value. Let's see if we can create one over here. Let's get rid of this. Let's get rid of this. Let's say y equals x. Let's do this. X plus 1 cubed minus 5. Nope. Minus x. There we go. That'll work. Okay. Let's blow this up a little and look at it. Step these by ones. Okay. Look at this graph. When the x equals negative 2.8, it's down here. But as the x's get bigger, so is the y. This is increasing. That is increasing right there. Until right here. Now the y's are going down. So on this side, it's increasing. On this side, it's decreasing. This is a relative maximum. It's not the maximum because I can find a bigger y over here. See, that y is bigger. That's 3.143. That's 3.729. That's bigger than the 1.385. So it's not the maximum, but relatively speaking, compared to everything around it, it's the largest value. Over here, it's 1.30. Over here, it's 1.288. Even right close to it, 1.36. That's still smaller. So this is called a relative maximum. and it's decreasing until here. This is a relative minimum because it's the smallest number. It's not the absolute max minimum because there's smaller y's over here. See, these are much smaller than 0.615. This goes on negative infinity. But it's increasing up until that point. It's decreasing down to this point and then increasing again. So if I wanted to illustrate that, here's a nice way I can illustrate that. So if I look at it this way, it's increasing till right there. That's all increasing. Where else is it increasing? Over here. Everything highlighted in yellow is where the graph is increasing. And then it's decreasing right here. Between that point and that point. Decreasing. D. All right, increasing I. And we can see that on a graph. It's harder to do that with an equation because you'd have to put in a whole bunch of values for x to figure that out. But we can graph that and say, I know where it's increasing. It's increasing in two different places. It's increasing from negative infinity all the way to x equals negative 1,577. From negative infinity all the way to there. Negative infinity to negative 1.577. That increasing, that's the interval. The other interval is when it gets bigger than negative 0.423 all the way to positive infinity. This is an increasing interval. This is an increasing interval. And of course, the decreasing interval would be from here to here. That's the interval where it's decreasing from that x to that x. So when we talk about intervals, we're talking about the x's. Because this x here starts all the way down at negative infinity and goes all the way up to there. And then this one starts there and goes all the way to positive infinity. Intervals. Intervals are x's, x values, x values. All right. So we see that increasing to that relative max, decreasing to the relative min, increasing again. And they show right here. It's increasing for x is less than negative 1.5 because that's where their relative max is. And also increasing for x is greater than 1.5. So that's the interval of increase. All right. And it's decreasing in between there. So that's another way you can write that. All right. Here's the formal definitions. Again, math language. Definition of increasing. x1 is less than x2 implies that any x we pick here is going to be smaller than any x we pick here. That means it's increasing. So if I say the x at negative 2.68 and the x at negative 1.57, that's where it's increasing because everywhere in between there, the y's are getting bigger. And actually, I'd go all the way to negative infinity in that case. It's increasing if for any x and any second x, the value, the y, is less than the y of the other one. If the y of x1 is less than the y of x2, that means it's increasing. So all that means is as the x value increases, so do the y values. That's all that means in simple language. If the x is going up and the y is going up, it's increasing. In the same way, as x goes up, y goes down means it's decreasing. The x's are getting bigger. See, the x's are getting bigger here still. X's are getting bigger. Negative 7, negative 0.2, 0.3, 0.8. The x's are getting bigger this whole way. From here on, that's always getting bigger x's. But what's the y's doing? Y's getting bigger, y's getting smaller, y's getting bigger. Constant functions. If they end up the same, here's a constant function. y equals 5. So that purple line there. It's a constant function. It's not increasing or decreasing. It's constant. It's constantly 5. Doesn't matter what the x is. See, the x starts at -6, y is 5. -3, y is 5. 0, y is 5. 4, y is 5. Constant function, which means just the y stays the same. Okay, relative minimum, relative maximum, as I talked about. See, that's the fancy language, is that there's an interval that contains a such that f of a is less than or equal to f of x. Relative minimum. It's like, what? It just means, going back to this one, the relative minimum or the relative maximum means that either side of that is a smaller y. So negative 1.577, 1.385 is a relative maximum because it's larger than both the values on either side of it. Relative minimum because it's smaller than the y on either side of it. That's all this fancy stuff is. Relative minimum, we see this as a low point, and this looks like a local high point, relative maximums. All right. Use the graph to find relative extrema, which extrema means maximums and minimums. All right, that's the extreme value. Looking at this area of the graph, and we can just look at that area of the graph. If we block out the rest of it and say, okay, I just want to see this area of the graph, what's the biggest part? Well, that's the highest part of it's right here. That's the largest value. That's right there. So that's the extreme highest value in this portion of the graph. That's called an extrema. And that's a relative extrema. All right. A graph has symmetry with respect to the y-axis if wherever there's xy, there's also negative xy. Saying what? Symmetry. Symmetry means it looks like a mirror. For example, y equals x squared. That formal definition said if 2,4 exists, if 2,4 exists, if it has symmetry over an axis, like this, we have the y-axis. The y-axis. That means if 2,4 exists, negative 2,4 should exist on the same graph. And it does. And we should be able to find more than one instance of that. If 1, 1 exists, that means negative 1, 1 should exist. And it does. So this graph has symmetry over the y-axis. Whatever's on the right side of this axis is a mirror of whatever's on the left side. Symmetry over y-axis. It could be symmetric due to the with respect to the origin. If it's respect to the origin, like this, this is symmetric with respect to the origin. That means if there's a 2, 4, there should be a negative 2, negative 4. Oh, but there's not a 2, 4. Let me choose a 1, 1 exists. So negative 1, negative 1 should exist. Where's a point that actually is over there? Let's say 1.5, 1.53375. 1.5, comma 3.375. Okay, that point exists. Let's label it. These don't, so I'm going to turn those off. Since that point exists, if I have the negative of both of those, that should also be on the graph. Negative 1.5, comma, negative 3.375. Yeah, both of those are on the graph. So that is like the origin is like a mirror. It goes up, goes down. Around the point 0, 0. 0, 0 is the symmetric point, the point of symmetry. And then, of course, with the x-axis would be same type of thing, but it would be y squared, something like that. Where 1, 1, that means 1, negative 1 would also exist. Okay, same thing up and down. symmetric around the x-axis. Last thing I want to look at is even or odd functions. Is that the last thing they have on here? I think so. Yeah, then we get to the actual lesson down there. Even or odd functions. Don't make this harder than it is. Okay. A function whose graph is symmetric to the y-axis is even. If it's symmetric to the origin, it's odd. Okay, let's look at these right here. This is even. It's a mirror on the y-axis. This is odd. It's mirrored through the origin. Right? This is not a function. You're like, what? That's right, because it fails that vertical line test. It's got two different values for the same x. This is not a function. So it can't be an even or odd function because it's not a function. The only thing that's even and odd is symmetric to the y, symmetric to the origin. So here's the way you test it. If you don't have a graph, but remember, you always have Desmos. You can graph it. For each x in the domain of f, f of negative x will equal f of x. It's like, what? Okay, let me show you how we're testing that for even. If we want to know if it's even, and let's say we're going to test f of x equals x squared. Is this even? It says we can take f of negative x and it will equal the exact same thing. We're looking for it to be x squared. If it equals the exact same equation. So that means we put negative x in for x, negative x squared. What's negative x times negative x? X squared. It does. It equals the exact same thing. So this is even. Make that exclamation point. Yes, it's even. Equals the same thing. Let's look at what happens if it's odd. For example, x to the third. Odd. Well, let's put negative x into it and see what we get. So what's negative x times negative x times negative x? Negative x times negative x is x squared. X squared times negative x is negative x to the third. So this equals negative x to the third. It's the opposite. So this is odd. We get the exact opposite equation. Now you got to be careful with that because if it's not so simple, let's say it's f of x equals x to the third minus x squared. And is this even or odd? Let's substitute negative x in. Negative x to the third power minus negative x squared. Well, we said negative x to the third power is negative x to the third power. Negative x squared is x squared. So this is minus x squared again. Looky there. Is that odd? Let's graph it and make sure. Let's see. Y equals x squared minus x squared. Oh, I put that on the one. All right, there it is. Oh, something looks wrong here. Oh, it's not. And we should have seen it's not here because is this the opposite of this? Well, this is the opposite. Negative. This was a positive x to the third, so it became negative. But this is exactly the same. This is the same as this. If this ended up opposite, if this was odd, then this would be negative x to the third plus x squared. That's the opposite of this. But that's not what we ended up with. We ended up with part of it was opposite and part of it was the same. This is neither. Neither. So that's your three options: even, odd, or neither. Neither one. Odd has to be exactly the opposite. Even has to be exactly the same. When you substitute negative x in there, it has to be the exact same equation or the exact opposite equation. If you get something that's a combination, this is a combination, that's neither. Has to be distinctly even, distinctly odd. So there you go. You will get the exact opposite of what you had to begin with if it's odd. So here's an example they give. They start with x to the fourth plus 3x squared plus 5. Let's graph that to see what they're looking at. X to the fourth plus 3x squared plus 5. Oh, stop that. That's way up here. It looks like it's going to be symmetric to the y-axis. When I graph it, looks like it's going to be the same. Let's see what their math shows. So they put negative x in for every x. So negative x to the fourth plus 3 negative x squared plus 5. So it ends up with x to the fourth plus 3x squared, and it doesn't show up very good as a squared. Right. It should be raised up. Plus 5. That's the exact same thing they started with. So it's even. And when we graphed it, we saw that symmetry. All right. And that is the end of the summary of the scenic overlook. If you need to get into more detail, there's plenty of pages down here where it talks about increasing, decreasing constant, all of that good stuff. All right. Quite a bit of stuff today. Then you have another 5-question assignment after that. Let me look at it real quick. Make sure it's just 5 questions. 1, 2, 3, 4. Oh, it's 4 questions. All right, let me put this up, though, because you need to look at it. You need to see this because it's not just a simple 5 multiple choice. We do have multiple choice here to determine the intervals on the function where it's increasing, decreasing, constant. All right. Where is it increasing? Where is it decreasing? Where is it constant? And apparently it's constant nowhere because none of the multiple choice gives you constant. Use the graph to estimate the local maximum and minimum. Whereas it looks like there must be more than one minimum because I see 2 low points. Which points are they? Determine whether this is even, odd, or neither. All right. So can you substitute negative x in there and negative x in there? And do you get the exact same equation, the exact opposite equation, or something that's neither one? Now, this number 4 is something you got to type this in. Give an example of a function that is neither. Now, yours may say different. Yours may say give an example of an even function or give an example of an odd function. Or you might have this one because it'll choose randomly which question you get. So you may not have this question. But the question that I was given here, my fake student, give an example of a function that's neither even nor odd and explain algebraically why it's not. Algebraically, that means substitute negative x into it and show that it's either the same equation, not the same equation, or opposite equation. Say, I have to have one that's neither. So I might want to go over here first and play around to come up with an equation. I may start with something simple. y equals 3x squared plus 5. And let's see if I substitute negative x for that. Let's see, I might could do that right here. 3 times negative x squared plus 5. Oh, look, it's the exact same equation. This must be an even one because when I put negative x in for the x's, I got the exact same equation. If this was to the third power, and I substitute negative x, I get a different equation. I get the exact opposite equation. So I can play around with this. And then algebraically, I have to substitute negative x in and show what it equals. So, all right. There you go. Just wanted to show you that before you get out of here. All right, guys. Longer class than I like, but we got a lot to cover. We're moving a lot in Algebra 3 here. So, unless you have some questions, I'll let you guys go enjoy the rest of your week. This is a B day this Friday. So Wednesday, if you have a grade below 70%, you'll need to be here. Otherwise, we'll see you next week.